In problem number 11, we're given a function and we are asked to determine intervals of concavity. In other words, we are asked to determine where the intervals where the function is concave up and where the function is concave down. The concavity of a function has to do with the second derivative of that function. Where the second derivative is positive, the function is concave up. Where the second derivative of the function is negative, there the function is concave down. So therefore, to determine the intervals of concavity, we need to calculate the second derivative of the function and then determine the values of x for which that second derivative is positive and the values of x for which that derivative is negative. First, we calculate the second derivative of this function, and of course to calculate the second derivative of the function we need to calculate its first derivative first. The function is a polynomial function, so we differentiate this function term by term using the power rule. The first derivative is 4x cubed minus 3x squared the derivative of the constant term, negative 2, in our function is 0, so that term basically just goes away. Let's differentiate one more time to get our second derivative. We'll get 4 times 3x squared minus 3 times 2x. And this is 12x squared minus 6x. Now we will set the second derivative equal to 0. And the reason we're doing this, even though we are interested in knowing where the second derivative is positive and where the second derivative is negative, we will first look for the points where the second derivative is 0. And that is because those points sort of separate the positive values of the second derivative from the negative values. This is an easy equation to solve. We can solve this by factoring. Factoring out the left-hand side, we get 6x times 2x minus 1 equals to 0. And so either x equals to 0 or 2x minus 1 equals to 0. And in that second case, x will equal to 1/2. So we found 2 points where the second derivative is equal to 0. And now we will draw the number line. Mark these 2 points on the number line. And we will use test points to determine where the second derivative is positive and where it's negative. So the 2 points that we found where the second derivative is 0 are x equals to 0 and x equals to 1/2. These 2 points divide the number line into 3 segments. These 3 segments are the segments where the second derivative is not equal to 0, and therefore it's either positive or negative. Sign of the derivative cannot change within one of these intervals, because if it did, then in order to change from a, say, positive value to a negative value, the second derivative would have to go through 0. But the only points where the second derivative turns to 0 are 0 and 1/2. So these are the only points where the change from positive to negative or from negative to positive values for the second derivative can occur. Therefore, we can determine where the function is positive and where the second derivative is positive and where it's negative by using test points. We'll select, for example, -1 as our test point on the first segment. We can select 1/4 right in the middle of the second segment. And then on the last segment, we can select 1, 2, 3. Really doesn't matter what exactly we select. Let me select 3. Next, we plug in these points into our second derivative. We do not care about the exact value, we just need to know whether the result is positive or negative. If I plug in the value of x equal to -1 into the second derivative, I'm going to get 6 times -1 times 2 times -1 minus 1. And so it's a product of a positive, negative, and another negative, and the result is going to be a positive result. And therefore, our second derivative will be positive on the first segment, and the function will be concave up. Now, repeat these calculations with the other test points. I will skip those calculations, just give you the results. At 1/4, you should get a negative result. And then at 3, you should get a positive result. So the function will be concave down on the second interval and concave up on the third interval. Now, let me look up what exactly the function, the problem was asking. The problem is asking to determine where the function is concave down, and so we just did that. We determined that the function is concave down between 0 and 1/2. So the correct answer choice is the interval from 0 to 1/2.